students, welcome back to my channel Chemistry with Saranya ma'am. So today I have come up with one more topic, that is conformations. In this conformations, we'll discuss the conformations of ethane and butane. So here, what are conformations? Conformations means here, these appear or arises. These arises due to rotation around carbon-carbon single bond. Here, what are conformations? Here, the structures appear due to the rotation around the carbon-carbon single bond. What will happen if the rotation takes place? So here, which leads to the change in the spatial arrangement of the atoms around the carbon atom. So these are called as conformers or conformations. Okay, here the spatial arrangement of the change in the spatial arrangement of the atoms around the carbon atom due to the carbon-carbon single bond rotation. Those are known as conformations. Okay, and now here we'll discuss the conformations of ethane. We'll discuss the conformations of ethane, CH3. Now the conformations are represented in two forms. First one is Newman projection, and the second one Saha's representation. So how these conformations are represented? These are represented by two ways. First one Newman projection and second one is Saha's representation. What are conformations? Which arises due to the rotation around the carbon-carbon single bond, and here because of that there is a change in the spatial arrangement. So here first we'll discuss ethane. How to write the Newman projections of ethane? So here this is the first carbon and it is the second carbon, you assume like that. Now here first carbon is represented with the dot, and here these are the hydrogens H1, H2, H3 around this carbon atom, these three hydrogens. Okay, these are arranged with a bond angle of 120 degrees, just you assume for your understanding sake. Now here C1 carbon is represented with a dot and C2 carbon is represented with a circle. So the circle is the second carbon atom, C2 carbon atom. This is C1 and it is the C2 carbon atom. Now here three hydrogens are there, no? So here the three hydrogens of this one, H4, H5, H6. This is the Newman projection. So here how these are represented. For example, here if you observe these two, here these two are like this. Here you assume this is the one carbon atom and it is the second carbon atom. This is the carbon-carbon bond. Here it is your H1 and H4 like this. So here if you observe, here just these two hydrogens are spatially closer, and here the angle between these two we call as, here the angle between the two atoms are the groups of the two adjacent carbon atoms. We call this as theta, which is a dihedral angle or angle of rotation, whatever it may be. Okay, so here if you observe this, here these two are spatially closer, and here the angle between these two hydrogens, here this hydrogen exactly it is backside of the first hydrogen. This hydrogen is placed, this is H4, this is placed exactly backside of the first hydrogen. Now the bond angle, it's not the bond angle, actually dihedral angle theta is equal to 0, and here this conformation we call as the eclipsed conformation. And if you observe that, if you observe one point here, these two hydrogens are spatially closer. As these two hydrogens are spatially closer, there exists a van der Waals forces of repulsion exist between them. So because of the van der Waals forces of repulsion, here there exists, there is an increase in the energy, which makes this conformation less stable. Okay, now about the stability and all we'll talk later. Now, so here this is about the dihedral angle and this is about the Newman projection, and if the dihedral angle theta is equal to 0, we call that conformation as eclipsed conformation. Okay, now here, now you fix the front carbon atom C1, just fix the front carbon atom C1 and rotate the back carbon atom to 60 degrees. So what will happen? This H4 will come this side and H2 will come this at this place, and H3 will come here. Now write the conformation. This is the first one we fix here, H1, this is H2 and it is H3. Just we have rotated this one. So here it is, the red one is the back carbon. So here is your H4 and here is your H5 and here is your H6. Okay, now what is the angle between these two now? 60 degrees, because 60 degrees we have rotated. Now rotate the back carbon, again you rotate to another 60 degrees from, so here just keeping the front carbon constant, and here is your H1, H2, H3. So here is your second carbon. So second carbon, if you rotate to another 60 degrees, this will come here, this will come here, this will come here. So H1 and here will be your H6 and here will be your H4 and here will be your H5. Okay, now next step. Okay, from here to here, if you observe, this is 1, this is 2 and this is 3. From here to here, we have rotated the back carbon to 120 degrees. Here 60 plus 60, 120 degrees. Now you rotate this to again 60 degrees. So here, if you keep on rotating these back carbon atom, you will get the conformations, and here finally you will get this one. You will be end with this eclipsed form. So among this eclipsed form and here in this, here the body 60 and here it is called as the staggered form. These two are the conformations possible for, this is eclipsed and it is staggered, in which the dihedral angle theta is equal to 0 and here the dihedral angle theta is equal to 60. So like this, a number of conformations are possible because of the carbon-carbon rotation. And here, because of the spatial arrangement, as these atoms are hydrogen 1 and hydrogen 2 are spatially close to each other, spatially closer, because of here the dihedral angle is 0 and here the dihedral angle is 60. And here experimentally it was evident that here eclipsed form is having 12.6 kilocalories energy more than the staggered form. So here energy of the eclipsed form is 12.6 kilocalories more when compared to the staggered form. So here, because of as the energy is more, here what about the stability? Coming to the stability, staggered form is more stable than eclipsed form. Staggered is more stable. Coming to the energy, eclipsed form energy is greater than the staggered form. So what are the two conformations possible for ethane? These conformations of ethane are important for your board exams and also for your competitive exams. So here what are the two stable conformations for ethane in the Newman projection? It is the eclipsed form and the staggered form. And eclipsed form, staggered form is more stable because the atoms are spatially far enough, spatially far when compared to the eclipsed form. Okay, so as they are spatially far, less repulsions and the conformation is more stable. Okay, now Sahar's representation. Sahar's representation of ethane, CH3. So here you write, this is the first carbon atom, second carbon atom, and first carbon atom hydrogens H1, H2 and H3, and the second carbon atom hydrogens, exactly here I am writing the eclipsed form, H4, H5 and H6. So it is the eclipsed form. If you view like this, here, if you view like this, here this is the C1 carbon, C2 carbon. Now write the staggered form. Staggered form will be obtained by rotating this to 60 degrees. So if you rotate this to 60 degrees, H4 will come this side, H5 will come at this place, H6 will come at this place. Now you write the staggered form of the ethane. So here as it is, first C1 carbon atom, C2 carbon atom, you keep the first carbon as it is, H1, H2 and H3. Here is your sixth carbon atom, H6, and here is your H4 and here is your H5. This is the staggered form of. Clear? Just you have rotated the back carbon to 60 degrees. These are at 120 degrees. So you have rotated to 60 degrees, half rotation, 60 degrees, 60 degrees. So you will get the staggered form. Okay. So this is H1 and it is H4. Like this. Okay. You assume like this. These two are, okay, like this. Like this. Okay, this is the less stable conformation. The conformation which is intermediate between the least stable and more stable conformation. Here I told you n number of conformations are possible. The conformations which are intermediate between these two are called as skewed conformations. Skewed conformations, which are intermediate between eclipsed and staggered conformation. Okay, this is about the Sahar's representation. Okay, in the next video we'll discuss the conformations of butane. Till then, bye.